Hello and welcome to mathandsciencepower.com. If you like what you see here, please remember to subscribe, comment, rate, and share. Okay, chapter 16, problem number 7 says, a charge of 6 millicoulombs is placed at each corner of a square 1 meter on a side. Determine the magnitude and direction of the force on each charge. So I'm going to start with a picture, which is usually a good idea. We know we have a square. And this square is 1 meter on each side. And at the corner, each corner of this square, we're going to have a charge. And I'm going to call these, let's see, Q1, Q2, Q3, and Q4. And all of these charges are the same. They're 6 millicoulombs. Okay, so here's our picture. Now, in previous problems, we worked with more than one charge, but they were all in a straight line. So that was a one-dimensional problem where we only left and right was the only way we could go. But now we have a square, so this is a two-dimensional problem. We have left and right and up and down. So when we go to sum our forces, we need to make sure that we sum them as vectors. So the same thing that we did in the previous problem, the total force on Q1 is going to be equal to the force between 1 and 2 plus the force between 1 and 3 plus the force between 1 and 4. So same kind of setup that we did before, just this time we have to be careful of the angles. So let's go ahead and look at the angles real quick. So Q1 and Q2, they're both positive, so they're going to want to repel each other. Q1 is going to want to go away from Q2 in this direction. Okay, this will be the force between 1 and 2. And Q4 and Q1, again, they want to repel, so Q1 is going to want to get away from Q4. So here's the force between 1 and 4. And then Q3 and Q1, again, they want to repel, so Q1 wants to get away from Q3. So here's the force between 1 and 3. Now when we do our vectors, where the charge is, we want to pretend that that is the origin of a coordinate plane. So I'm just going to draw a coordinate plane here. And this direction is going to be the positive x, and this direction will be the positive y. So when we do our vectors, we always want to measure our angles from the positive x-axis. So the force between 1 and 2, well, let's start over here. The force between 1 and 4 is at 180 degrees. Okay, the force between 1 and 3 is at 135 degrees. And then the force between 1 and 2 is at 90 degrees. Okay? And then the same thing as before. To find the forces, we need to use Coulomb's law. So the force between 1 and 2 is going to be K times Q1 times Q2 divided by the distance between them squared. The force between 1 and 3 is the same thing, K, Q1, Q3 divided by the distance between them squared. And the force between 1 and 4 will be K, Q1, Q4 divided by the distance between them squared. So the distance between 1 and 2 is easy. If they told us it's 1 meter, it's the same thing between 1 and 4, it's 1 meter. But between 1 and 3 is not 1 meter, it's going to be something different. So let's draw this line here. And here you can see this is a right angle. So this is a right triangle. And the sides, each leg is 1 meter. We need to find the hypotenuse. So we'll just use Pythagorean theorem. a squared plus b squared equals c squared. So I know that a and b, the legs, they're both 1. And we're looking for c squared. So 1 squared is 1, 1 squared is 1, so 1 plus 1 is 2. And I just need to take the square root of both sides to get c by itself. So the square root will cancel the square. And we get the square root of 2 is equal to c. So this length here is the square root of 2. So now I know what all of these distances are, and I know what the charges are, and again k is our constant. K equals 9 times 10 to the 9th Newton meters squared per Coulomb squared. So again, these formulas, they're only going to give us the magnitude of the forces, and we've already determined the directions, so let's just figure out what the magnitudes are here. Okay, the force between 1 and 2 is going to be K, which is 9 times 10 to the 9th Newton meters squared per Coulomb squared, times Q1 times Q2. Now they're both 6 millicoulombs, which is 6 times 10 to the negative third. So when I multiply them together, I have 2. I'm just going to square that. And then I'll divide by the distance between them squared, which is 1 meter squared. So we'll just plug this in and see what we get. We have 6 with an exponent of negative 3. I'll square that because that's Q1 and Q2 times each other. 1 meter squared is still just 1, so if I divide by 1, that doesn't change the number at all. But then I need to multiply by 9 with an exponent of 9. Okay, and we get 324,000. So 324,000. And our units, we've got meter squared in the numerator, meter squared in the denominator. These are coulombs. So coulomb squared in the denominator, we'll cancel coulomb squared in the numerator, and we'll be left with newtons, which is our force. Okay, and the force between 1 and 3, same thing. Okay, both charges are still 6 millicoulombs, so I'll just square that. But the distance between them, remember, is the square root of 2 meters, and then we square that. So the force between 1 and 3 will be, so we've got 6 with an exponent of negative 3. I'll square that. Now when I take the square root of 2 and I square that, that just gives me 2. The square root cancels the square. So I'm just going to divide by 2. And then we'll multiply by 9 times 10 to the 9th. 9 with an exponent of 9. Okay, and we get 162,000. Okay, and our units will cancel the exact same way. Meter squared, Coulomb squared. And I forgot again to put my coulombs in here. Okay, and we're left with newtons. Okay, so the force between 1 and 4 is going to be the exact same thing as 1 and 2 because the distance between them is the same, the charge is the same, and K is the same, so we're going to get the exact same number. It's going to be 324,000 newtons. Okay, the only thing different here is the direction. Okay, so see 1 and 2 goes vertical in the positive y, and 1 and 4 goes horizontal in the negative x. But the magnitudes are the same, just the directions are different. So now that we know our directions and we know our magnitudes, what I like to do now is, since these are vectors and we need to add them, I like to use a chart. So I've already drawn the chart here. And we just need to fill in the numbers. So I'm going to label these here the force between 1 and 2, the force between 1 and 3, and the force between 1 and 4. So the magnitude between 1 and 4 were both 324,000 newtons. Okay, and the force between 1 and 3 was 162,000 newtons. Okay, and now in this column I'm going to put the angle. Okay, so remember between 1 and 2 was 90, 1 and 3 was 135, and between 1 and 4 was 180. So 90, 135, and 180. So we've got 90 degrees, 135 degrees, and 180 degrees. So now what we need to do is calculate what is the x component of these forces and what is the y component. And to do this, all we do is the x component is equal to the magnitude of the force times the cosine of the angle. So here's our angle, and here's the magnitude. And then the y component is the magnitude of the force times the sine of the angle. Okay. So let's start here. I'm going to take the cosine of the angle first. Make sure my calculator is in degrees. So I'm going to do 90, and then cosine, which is 0. So when I multiply by the magnitude of the force times 324,000, I'm just going to get 0. So here the x component is 0. And you can imagine that the sine of the angle then, if I take 90 degrees and I take the sine, well, that's 1. So when I multiply by 324,000, I'm just going to get 324,000 newtons. Okay, and that's pretty intuitive if you look at the picture. This force, everything is in the positive x. There is no left or right. It's all straight up. It's not at an angle at all. It's straight up. So the whole thing is in the positive y, which is what we got here. The one that will be interesting is this one, the force between 1 and 3. We will take the cosine of the angle, which is 135. So 135 cosine, 135 cosine, and then we will multiply by the magnitude, which is 162,000. So times 162, 1, 2, 3. And we get 1145.51. And notice that it's negative. This is important. Okay, so 1145.51. And it's negative newtons. So now we'll find the y component, and we'll just take the sine of the angle this time. So 135 is the angle. We'll take the sine, and then we will multiply by the magnitude, which is 162,000. Okay, I get the exact same number, but this time it's positive. Okay, so this is just going to be 1145.51 newtons. And then the last one, the angle this time is 180, so 180 cosine, which is negative 1, and now we'll multiply by 324,000, and we get negative 324,000. Okay, and you can probably guess what the last one is. The sine of the angle is going to be 0. So we'll take 180 and the sine is 0, and so when I multiply by 324,000, I just get 0. Okay, so now we found all of our components. Now what we need to do is add these together, right down the column. So I'm going to start here with the x components. We have 0 plus negative 114,551, so 1145.51, but that's negative. And then I'll add 324,000, but that's negative, equals, and I get negative 438,551. Negative 438,551 newtons. And then I'll just do the same thing in this column. And you can see these numbers are the same, except these are positive and these are the negative. So I'm going to get the exact same number, it's just going to be positive. So 438,551 newtons. So when I add these together, this bottom row is going to give me the resultant. Okay, that's going to be the bottom row. Now we just need to figure out what is the resultant force and what is the resultant angle. So to find the resultant force, we need to use Pythagorean theorem. So basically what we're doing here is the x component is negative. So that's to the left, 438,551 newtons. The y component is positive, so it's vertical, and it's 438,551 newtons. And we are looking for the hypotenuse. This will be the resultant magnitude of these forces. So we just use Pythagorean theorem. So a squared plus b squared equals c squared. We'll have 438,551 squared plus negative 438,551 squared, and that will tell us what c squared is. Okay. So I've already got the negative answer here typed in, I just need to square it. Now I need to add 438,551 square that equals, now this is telling me c squared, so to find just c I need to take the square root still, and I get 620,204. Okay, so 620,24. 620,24, and that's c. Because remember we took the square root of both sides here after we did this, so that we could get just c. So this is the resultant magnitude. We'll put this in our chart. Okay, and that's newtons. And now we just need to find the angle, the resultant angle. We are looking for this angle here. So we already know the opposite side of the angle and the adjacent, so that sounds an awful lot like a tangent function. So the tangent of this angle is going to equal the opposite divided by the adjacent. But if I want to know the angle, I'll take the inverse tangent of both sides. So the angle is the inverse tangent of the opposite over the adjacent, which is the inverse tangent of the opposite side is 438,551, and the adjacent side is negative 438,551. Okay, so we just need to type this into our calculator. I'm going to start with what's in the parentheses, and obviously these numbers are the same, one's positive, one's negative, it's just going to give me -1. So I know that when I divide this I'll get -1, and then I need to take the inverse tangent, and you can see it says -45 degrees. Now this is a little bit misleading, because it doesn't matter whether this side was negative then this one was positive, or if the horizontal was positive and then the vertical was negative. When I divide them, the opposite over the adjacent, I'm still going to get -1. So the calculator doesn't know whether I want this angle here, which is -45, or this angle here, which is actually 135. Okay, the calculator doesn't know what I want, but it's this one I want. You really got to look at the picture to determine what the correct answer is. Sometimes you need to add 180 to the answer that you get. So we expect the resultant to be up in this direction, which is 135. So our angle will be 135 degrees. And now we'll just write the final answer. So the net force on Q1 is going to be, I'll just round the magnitude here to 6.2, and then that will be times 10 to the 5th power. So 6.2 times 10 to the 5th. And then we'll use the angle symbol, because this is a vector, and the angle is 135 degrees. Okay, and again, the question did ask us to determine the magnitude and direction of the force on each charge. The magnitude, you can calculate this again if you want, but the magnitudes are always going to come out the same. The only thing different here is going to be the angle. So for example, this angle, the resultant came out to be 135. If you do it for Q4, it's going to come out to be 45. If you did it for Q2, it would be, let's see, what is that, 225? And if you did it for Q3, that would be 315. So I'm not going to spend the time doing that. You can if you want. The magnitude should come out the same. The angles are what will be different, because these values, the signs will change, and that indicates to you what quadrant you're in. So this will be good enough for us for now. On behalf of mathandsciencepower.com, thanks for watching.